Hi, my name is Ignacio Peluaga, and in this session, I will present and demonstrate our cloud benchmarking and validation test suite. Cloud services move beyond the traditional infrastructure, platform, and software as a service models. Benchmarking and validation starts at infrastructure and goes up the stack all the way to the software layer. Services have to be validated to multidisciplinary research use cases. There is a need of a tool to automate deployment, benchmarking, and validation of cloud services. Among other things, such a tool should provide flexibility to onboard commercial clouds and satisfy diverse research workloads, facilitate comparison of cloud services, use open and vendor-independent tools, validate exit strategies between providers, and foster wider adoption of cloud services by the research community. Feedback was gathered from the testing activities of the HNSI Cloud project in 2018. In 2019, the first version of the suite was used in the Okra project. Currently, the suite serves as a base for the Archiver project test suite. In the long term, the suite is expected to become part of the European Open Science Cloud. The tool is written in Python, uses Terraform for provisioning resources, and Ansible to bootstrap a Kubernetes cluster. This means the tests run on Docker containers. For configuration, YAML is used, and for results, JSON. The result files are optionally pushed to a bucket on the CERN cloud. A Node.js verification service is currently being developed to achieve results integrity. The test catalog, constantly evolving and growing, should cover a wide range of IT areas. Not only infrastructure like compute, networking, and storage, but also higher levels such as protocols and software. It is important to point out that most of the tests integrated in our suite are contributions from the scientific community in Europe. Now, let's have a look at the process. First, the user clones the repository. Following, configuration is done by filling two simple YAML files. After the configurations, the tool is run. The suite will provision virtual machines, and once they are ready, it will bootstrap a Kubernetes cluster. The suite creates Kubernetes resource definition files according to the provided test configurations. The pods are deployed using these YAML files, and the containers running on the pods use test-specific images. When the test pods are ready, the suite runs tasks remotely, either by sending a script to the pod and triggering it, or a command defined on the Kubernetes resource file that created the pod, or by a job triggered by the specific Docker image itself. Once the test complete, the test suite harvests the resulting JSON files from the pods using kubectl. Once all results are harvested, pods are killed and resource optionally destroyed. As part of the development and testing of our suite, we have deployed it on most of the main cloud providers, as well as on popular cloud management platforms. For the demonstration, we will be running on the Swiss cloud provider Exoscale. As an example, the CPU benchmarking and network test will be deployed. On completion, a second run will be performed, skipping the provisioning phase. Eventually, we will look into the obtained results, and at the end of the run, the provisioned virtual machines will be destroyed. Here I have cloned the repository and have prepared as well the configuration files. The configs file contains details required for provisioning the resources, like the authentication for the provider on which the deployment will be done, the path to the SSH key, as well as the flavor for the VMs and the operating system, among others. The other configuration file is the test catalog file, which contains details specific to the test to be deployed. Here I have selected the CPU benchmarking and network test. Now it's time to start the suite. The command line options C and T specify the path to the configuration files. While the suite is running, the logs file will contain the Terraform logs. When the Terraform phase is done, the Ansible logs file will show the output of the Ansible steps. This will show logs related to configuring VM's firewalls, package repositories, installing dependencies, to finally initialize the cluster and make slaves join the master node. When the Ansible phase is completed, the suite deploys the test using the YAML definition of the resources. The command kubectl get pods will show the pods being created on the cluster first and then running. When the test run completes on a pod, the suite will collect the results file and finally terminate the pod. Once all tests have completed, the suite finishes its run. The path shown on the header of the logs contains the results of the run. That directory contains a general.json file containing details about the run, as well as an estimated cost if the user provided the resource's price in the configs file. Alongside the JSON file, there is a folder named detail containing the result file of each test. Here we can see the result file of the CPU benchmark run, and also the result file of the network test. Now a second run will be performed. In this case, the provisioning and bootstrapping phases will be skipped as the cluster is still created and running, as can be seen on the right-hand side of the screen. To do that, the option only test will be used in the command. Also, the option destroy on completion will be used now to tell the suite that the VMs should be destroyed at the end of the run. Pods are being created. And all pods are running now. When tests complete, results are harvested and pods destroyed. Because of the destroy option that was used in this run, after all the tests complete, the suite destroys all the provisioned VMs. And once again, it can be seen that the results were collected. We are constantly working on improving the suite. A few of our next steps are use deployment or job instead of pod, allow talking to a cluster behind NAT, work on new tests and update the existing ones, increase setting and configurations, and build a dashboard to see results in a human-readable way. For more information and details, you can check out the repository and the documentation. Also, you can contact us directly by email. We will really appreciate your feedback. Thank you very much for your attention.